In order to achieve this, we really had to design the factory as a machine. So a lot of the way that people look at factories is kind of, it's often thought of as kind of like a boring thing, like making photocopies or something. It's just like boring, it's like catalog engineering. But this is totally the wrong way to look at it. You really need to look at a factory like it's a product, like it's a giant machine that builds the machine. And it deserves actually more innovation and more engineering skill than the product itself. And that's what we've done with the Gigafactory.
Yeah, we have some of our best engineering teams working on actually laying out the factory and looking at how to fit more density and more equipment into the same footprint. And this is really key to how we've been able to reduce the cost of the cells and the batteries that come out of here so much. That intense engineering effort is what drives this improvement. It's not just, as Elon said, it's not a copying machine. It's not just replicating things that have been done before. We're reinventing that battery manufacturing process from end to end.
Yeah, in fact, I can't emphasize enough how important this conceptual framework is. Because really, almost everywhere, they just think of the factory as a bunch of machines, like basic machines that are stuck together to produce copies. And it's mostly pulled from catalogs. You'll get this machine from that person, that company, this machine from another company. But if you applied that same principle to product design, it wouldn't make any sense. Like if we try to make the Model S out of parts from a bunch of different cars, it would be ridiculous. It would be like a bumper from a Honda, a steering wheel from this, a motor from something else. It would look like a right, exactly. It wouldn't make any sense to actually make a car from bits and pieces of other cars. You really need to design the car as an integrated product from the ground up. And that's the same approach we've taken to the Gigafactory, and it's really quite unusual for that to be the case. So, yeah, and then in terms of analyzing how the factory should work, I'm a big fan of using physics as an analytical framework for physics. Yeah. Physics is true. Everything else is debatable, and even physics is questionable. So, designing the factory from physics first principles means really optimizing the density of the factory. So you can think of like the fundamental efficiency of the factory is the density of useful stuff. Like what percentage of the volume of the factory is actually useful stuff versus not useful stuff. And then the output of the factory is the exit velocity of products from the factory. So we're actually just applying that throughout, or through every step of the process. We're actually fairly confident that there's at least maybe a 5 to 10-fold, at least 5, I think, and maybe 10 or more fold potential improvement in production capability.
And this image you guys can see, maybe some of you can see on the screen, is actual CAD of the factory. Just like a great machine, the entire factory is in CAD. Every pipe, every electrical conduit, every piece of ductwork, and every piece of equipment building the cells. So we've modeled all that to fit it in, with the minimum wasted space. Everything is basically almost touching each other on every floor. So that was necessary to build this amazing machine. And many factories aren't done this way. You build a shell and then you sort of randomly put equipment in there. But this was very different.
Yeah, it's essentially designed like a very high density, multi-layer integrated circuit, like an advanced CPU, which is really, actually when you think about it, it's like obviously how it should be done. And I think actually over time, the manufacturing process may look a lot like one of those super fast chip pick and place machines. It's super optimized for speed and density. If you think about how did we improve the capability of your phone or your laptop? It wasn't by making a really giant computer the size of a table. It was by increasing the clock speed and the density. And those same principles apply to manufacturing. So I'm really excited about revitalizing manufacturing. I think it needs love, and we're going to give it.